Hello all, I am Dr. SV and this is lecture 3 on Mohr circle. In the previous two lectures we have discussed the assumptions that we make while drawing the Mohr circle for the elements subjected to stresses. In the second lecture we have discussed few cases of how to solve the Mohr circle problems. In this lecture too, we will discuss two or three or more cases regarding Mohr circle. So let us start with case 5. Mohr circle for an element subjected to two mutually perpendicular stresses. In this, let us consider the diagram as this. This is the element that is subjected to two stresses sigma y and sigma x. This is the oblique plane. We have to find out the value of normal stress and this tangential stress sigma t on this plane. These are the two stresses. Let sigma x be 100 kilonewton per meter square. Sigma y equals to 40 kilonewton per meter square. This is an example. We will first scale our stresses. Let 1 centimeter equals to 10 kilonewton per meter square. So sigma x will be equals to 10 centimeter and sigma y will be equals to 4 centimeter, and they will be represented from the origin as OA and OB. So now let us draw the axis y and x. Since both the stresses are like and they both are tensile, so they both will be plotted on positive x-axis. This is y-axis. This is the origin. We'll do the marking through scale 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 centimeter. At 10 centimeter, we'll mark the point as A and this will be representing the value of shear stress sigma x. Sorry, the value of direct stress sigma x. And at 4 centimeter, we'll mark the point B and this will represent the value of normal stress sigma y. Now we'll mark the center of point A and B and let that point be C. With CA as radius or CB as radius, we'll draw a circle. This will be the Mohr circle for an element subjected to two mutually perpendicular stress. We have also discussed in our assumption that the theta angle of the element is taken as twice the angle, that is 2 theta on Mohr circle. So with C as center, we'll measure angle 2 theta. Let theta be 30 degree. So 2 theta will be equals to 60 degree. We'll mark 60 degree here. We will extend this line to the Mohr circle and we mark this point as point D. From D we will drop a perpendicular on x-axis and mark that point as E, and we will join point O and D. Now this distance DE, this is the tangential stress sigma T. We'll measure it from scale and we'll multiply by the scale equals to 10 kilonewton, and we'll find out the value of sigma x, sigma T. And here you can see that OE is equals to the normal stress sigma n, and this OD will be equals to OD is equals to the resultant stress sigma R. These all values will be measured through scale, and we will measure this angle through protractor, and this is phi. Phi is angle of obliquity. If question asks you to find out the angle of obliquity, you will use protractor and you can find out the value of phi. This is case 5. How to solve a numerical on Mohr circle for an element subjected to two mutually perpendicular stresses. There may be case when both stresses are unlike. That is, one stress is tensile and other stress is compressive. This we will discuss in case number 6 for unlike stresses. Let sigma x be tensile in nature and sigma y be compressive in nature. Y. Here also we will take some value to draw the Mohr circle. Let it be 100 kilonewton per meter square and 20 kilonewton per meter square. We will scale it initially and let 1 centimeter equals to 10 kilonewton per meter square. So sigma x will be equals to 10 centimeter equals to OA and sigma y equals to 2 centimeter equals to OB. Since one stress is tensile and the other is compressive, so the tensile one will be represented on positive x-axis and the compressive one will be represented on negative x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At 10 centimeter we will mark point A and it will represent sigma x, and at -2 we will mark point B and it will represent sigma y from the origin. And now with C as center, it will be somewhere here 1, 2, 3, 4, 5, 6. With C as center and C as radius, we will draw a circle that will pass through A and B. This will be the Mohr circle for an element subjected to two mutually unlike perpendicular stresses. Similar to the previous case, we will mark angle 2 theta from C and we will extend this line and it will cut Mohr circle at point D. We will draw up a perpendicular from point D to x-axis and it will meet x-axis at point E. We will join O and D. Here also DE will represent the tangential stress, OE will represent the normal stress and OD will represent the resultant stress sigma r. We can find out the value using scale, and here this angle will be the angle of obliquity for this problem. So the last case is the Mohr circle for an element subjected to direct stresses along with a simple shear stress. Now we will discuss case 7. Case 7. Mohr circle for an element subjected to two mutually perpendicular stresses with simple shear. For this we will first see the diagram. This is sigma x acting along x-axis. This is sigma y acting along y-axis, and this is shear along this plane, and this is shear along sigma x plane, tau and tau. This is theta. This is the diagram for which we have to draw the Mohr circle. And again we will assume the values 100 kilonewton per meter square, sigma y 40 kilonewton per or 20 kilonewton per meter square, and tau equals to, let us say that it is 10 kilonewton per meter square. We will scale it. Let 1 centimeter equals to 10 kilonewton per meter square. So sigma x equals to 10 centimeter, sigma y equals to 2 centimeter, and tau equals to 1 centimeter. Again we will draw the axes, x axis, y axis, origin 1, 2, 3, 4, 5, 6, 8, 9, 10. We'll mark this point as A, we'll mark this point as B. This is sigma y, then this is sigma x. We'll mark this point as C, center. But this is not the center for this case. In this case, we will also represent tau that is acting along the two planes. Tau, when producing clockwise moment, is considered as positive, and when it is producing anti-clockwise moment, it is considered as negative. We can see here that on this plane in which here on this plane where sigma x is acting, the shear is rotating the element in anti-clockwise direction, so it is considered as negative. So we will mark 1 centimeter from here downward and mark this point as D. And for this plane that is carrying sigma y, it is having a shear that is rotating the element in clockwise direction, so it will be considered as positive, and we will mark this as point E, 1 centimeter above, because shear stress is marked or denoted in y axis. Now we will join these 2 points using in scale E and D, and it will cut the x-axis. The point at which it cuts the x-axis is the center of the Mohr circle. And now with CD or CE as radius, we will draw a circle. This will be the Mohr circle for an element subjected to two mutually perpendicular stresses with simple shear. Now again we will mark the theta angle as 2 theta on the Mohr circle. If it is theta equals to 30 degree, we'll mark it as 60 degree on Mohr circle. So we will mark it from CD from here. Now we'll again extend this line, and the point at which it cuts the Mohr circle, mark this point as F. Again drop a perpendicular from F on x-axis and mark this point as G. Join O and F. Again you can see that this here from F to G, it is tangential stress. From G to O, it is sigma n normal stress. From O to F, it is the resultant stress, and we can measure using protector this angle FOG, and this is the angle of obliquity. So now you will be able to solve all the type of numericals on Mohr circle. Thank you.